Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Magnetic Pole Shift and Crustal Displacement. Now, as detailed in Article 161, magnetic pole reversal, is it causing deep changes to our planet? The Earth's magnetic poles are shifting, and that shift has sped up dramatically in the last 50 years. In order to understand what is causing this, we need to understand what produces the Earth's magnetic field. In this article, I'll start by examining the source of the Earth's magnetic field. And here we see the shift that has occurred in the last 50 years. And certainly in the last 10 years, it has greatly accelerated because the magnetic North Pole moves from this position to that position in 50 years. But in the last 10 years, it moved from here to there. So it moved half the distance of the total movement in 50 years. So this shows an acceleration. Also, the magnetic field is moving in a straight line towards Russia. Now, here we can also see the speed of the shift, as it shows the shift per year in kilometers. You can see it for 420 years, and for most of that time, these were small shifts. But lately, since 1980 and definitely from around the mid-1990s, there has been an increase in the speed of the shift. As you can see, it went straight up. There's one here, went up to 70, above 70 kilometers per year. And this, I think, was the year 2000. So this shows a huge increase in the speed of that shift. Now, the Earth's magnetic field is thought to be produced in the liquid outer core of the Earth. It is believed to be generated by electric currents derived from conducting elements like iron in the liquid core. The currents are believed to occur as a result of convection currents due to heat escaping from the core and aided by Earth's rotation. However, convection currents are by nature unstable. Convection currents move hot water, for instance, from the bottom of a pot of water heating on the stove, and are also created by fans which can be used to circulate air. But the direction of the currents are only broadly organized, and you may get more flow from one side of the bottom of the pot, for instance, than another at any time. Thus, convection currents, and they will rotate, even though they broadly from the bottom to the top, they will rotate. So they will change and change quickly. Thus, convection currents in the outer core of the Earth should result in the poles moving around all the time. The magnetic North Pole would be on one side of the geographic North Pole one day and move to the other side the next, as the convection currents swirl around, taking hot liquid core from the inner core towards the mantle. And this is illustrated here. So the inner core is hot, and you expect heat to produce currents like in a pot of water on the stove heating up. The bottom gets hot, and then you get these currents flowing outwards. But they can start out flowing this way, but they can quickly shift to going in another direction. And if the Earth's rotation is what determines the direction that it goes in, even then it wouldn't be able to stabilize such a flow. It would be erratic. It would never create magnetic field lines that would stay in place day after day. So the Earth's magnetic field seems to be much more stable than what this kind of mechanism can produce. And this will indicate that the Earth's magnetic field is more like that of a permanent magnet. And I just wanted to mention, so the Earth's rotation is supposed to stabilize this kind of current, but if the Earth's rotation is able to balance the magnetic field, and therefore by balancing these currents, then the magnetic North Pole would coincide perfectly with the geographic North Pole, but it does not. The two axes, the magnetic axis and the rotational axis, are at 11 degrees to each other. So the rotation cannot balance it. Now, Halley's Comet was found to have a magnetic field, and comets are just rocky objects like asteroids, as asteroids also develop a coma and a comet's tail when their orbits are not circular. The appearance of the coma and the tail is an electrical effect resulting from its non-circular orbit in the solar system. And according to James McCanney, comets are rocky objects, not dirty snowballs, which discharge in the solar system where the sun acts as a capacitor, with the sun's surface being the inner negative plate and the positive plate being at the edge of the solar system and made up of mainly hydrogen nuclei. We also know that the stellar cores, which have been extensively observed in the sun's corona, and I have been writing about them, must have very strong magnetic fields, and yet they seem to be completely solid, with the surface of the core being able to restart emitting visible light after being in the sun's corona for some time and absorbing energy from the sun. The stellar cores have no liquid layer to produce a magnetic field, but yet they have a magnetic field, which means that no liquid layer is necessary to produce a magnetic field. In addition, the sun is mainly solid. The photosphere, which is the surface of the sun that emits the light that we see as visible light, is solid, and it has holes in it called sunspots. And the chromosphere is semi-liquid. It's more solid at the bottom, and as you move further up, it has the consistency of a thick liquid, and it's quite a bit like lava. Whilst the corona is gaseous, it's the atmosphere of the sun. The sun's magnetic field seems to, however, be generated below the photosphere and not in the chromosphere, the part that is more liquid. So even the sun seems to generate a magnetic field without any need for a liquid layer to produce it. And here we see the blue stellar core. As you can see, it has a solid surface. We can see grooves in it. So this is actually the core of the object. That's why I call them stellar cores. And it had started emitting blue light from the core itself. As you can see, there's some, this portion here is brighter than the rest. So it was emitting more light, brighter light from this region. It had some material clinging to the core, but this material was not in the liquid phase. It was in the solid phase. It seemed to be crumbly. The object seemed to be shedding this material, but it was accumulating a corona, and that is gaseous plasma, through a connection that it was making with the sun or other stellar cores. But this shows that it had to have a magnetic field in order to make that connection. And this gaseous plasma was emitting magenta light. So celestial objects can have strong magnetic fields without the need for a liquid layer. Now, the Earth's core is likely to have a lot of iron in it, and there must have been a time when the Earth's core during the planet's formation was extremely hot, and therefore melted. It is likely that the core formed first. It may have been ejected from a star and then become a protoplanet or comet in the solar system, acquiring more layers each time it moved inwards towards the sun at the same time as its orbit became more circular, as suggested by James McCanney in his book Planet X, Comets and Earth Changes. The forming planet must have therefore gone through a cool-down period which solidified the core. If the core was immersed in a magnetic field during this time, then as the core cooled below the Curie temperature, which is the temperature below which ferromagnetic have aligned magnetic moments or permanently magnetized, but above that they are not permanently magnetized. So the core would become a permanent magnet, and its magnetic field would have the same orientation as the magnetic field it had been immersed in. This is also how permanent magnets are manufactured. Iron is heated above the Curie temperature and then allowed to cool back down, whilst immersed in an external magnetic field. Once the iron cools back down below the Curie temperature, which is 1042 Kelvin for iron, it has become a permanent magnet. So the most likely way that Earth's magnetic field was generated was that the Earth started out with a core which was a permanent magnet, and then other layers condensed onto the core. Those may also have cooled down in the presence of magnetic fields and thus become a further contribution to the Earth's permanent magnetic field. It is this field which causes compasses to roughly point towards the Earth's North Pole. Unless the compass is over a region on the Earth's surface which has a strong localized field with a different orientation to the Earth's main permanent magnetic field. So this illustrates what we have. We have a solid core, and the solid core has a permanent magnetic field illustrated by the gray arrow. Then there's a liquid layer, and above that there is the outer mantle and crust, which are also solid and which also have a magnetic field. And this is the net direction of that magnetic field, because this outer region was deposited at different times, and it has different regions with magnetic fields with different orientations. So it's possible that they may be close to the surface regions where the magnetic field is different from the overall magnetic field of this layer of the Earth. Now, the total magnetic field is illustrated by the green arrow, and we obtain this total magnetic field by adding the two contributions, the gray one from the inner core and the purple one from the outer solid layer of the Earth. And the Earth's magnetic North Pole is aligned with the main magnetic field obtained from these two permanent contributions, and this gives rise to Earth's permanent magnetic field. But the field also has non-permanent components, and these are created by the interaction of the solar wind with the Earth's permanent magnetic field. So solar wind ionized particles form circular currents around the Earth's atmosphere in a layer of the atmosphere called the ionosphere. These also lead to currents being induced inside the Earth's liquid outer core and lower liquid magma, which also produce a contribution. However, these non-permanent components align themselves to the permanent magnetic field and thus will have the same orientation. In other words, they do not tend to change the Earth's North Pole, but rather align with it. And here we see illustrated the currents of ionized particles which come from the solar wind in the ionosphere. And we have positive ions moving towards the west in these temperate zones or the tropics, whilst along the equator we have the electron ionospheric stream in the traveling in the opposite direction towards the west. And again, in the tropics we get another positive ion stream, and these would be in the ionosphere, the upper layer of the Earth's atmosphere, which receives has contact with solar wind particles. Now, the other non-permanent part is due to induced currents created inside the liquid layer of the Earth. So this is the solid layer, this is the inner core. Also part of the mantle would be part of it, because part of the mantle would be melted as well. And but these currents are not at all like the spiraling currents that is believed to create the Earth's magnetic field. These are actually circular currents which go right around the core. So why is the Earth's magnetic north pole shifting? The Earth's non-permanent portion may vary slightly as a result of an interaction with the sun's solar wind, but this should only result in the magnetic pole shifting slightly and in random directions. And this would also change the direction of the magnetic field according to whether the Earth's magnetosphere is being impacted by energetic events, solar flares, CMEs, and so on. But the magnetic north pole is shifting in one direction. It is moving towards Russia, and it is accelerating. It's not moving backwards and forwards. Heating inside the Earth and melting of regions that may have had a permanent magnetic field and thus made a contribution to the Earth's overall magnetic field may be one reason why the Earth's magnetic field is changing. So this is one possibility, but there are other possible explanations for this shift in the magnetic poles, and in particular in one direction, that is towards Russia. The shift in the poles was actually in random directions until around 1980, when it suddenly accelerated, started moving in one particular direction. So, since the position of Earth's magnetic poles comes from the Earth's permanent magnetic field, this field would have to change in order for the position of the poles to change. And this suggests that the relative positions of the solid core and the outside mantle and crust have changed. In order for this to occur, periodic small crustal displacements would have to occur, which is only possible if a large body, a massive object, moves quickly past the Earth, causing tidal waves both in the oceans and in the liquid layer under the crust and upper mantle. This wave can then cause a crustal displacement. The moon causes tidal forces on the Earth that affect Earth's oceans and leads to high and low tides. But these tidal forces are not large enough to cause a crustal displacement. The fact that the shift is in one direction only indicates that the tidal forces exerted is in the same direction. The tidal force exerted in the same direction. If a massive object repeatedly approaches the Earth, then we would expect an event each time. But these would not be likely to be in the same direction. The fact that the shift is in one direction suggests that an object makes regular passes close to the Earth and may therefore be in orbit around the Earth, on a highly elliptical orbit, so that it gets very close at its closest position. The rest of the time it's too far to have an effect. So we have two possibilities. The moon's orbit has changed. It's now highly elliptical, and the moon comes very close to Earth at periodic times, causing a greatly increased tidal force, leading to a small crustal displacement each time. Or 2, the Earth has acquired a new moon which follows a highly elliptical orbit. And is thus causing an increased tidal effect on the Earth and leading to small incremental crustal displacements. And this illustrates what is possibly happening. That the moon, whether our original moon, which has moved to a very elliptical orbit as illustrated here, so at times it will move very close past the Earth, causing these fast moving tidal events, and the tidal event would then be on the ocean, and it would be inside the inner part of the Earth that is liquid. And if it's fast moving, then it may cause a shift in the solid outer layer of the Earth. Now, if a moon is moving into a highly elliptical orbit, then in its perihelion position, or its closest position to the Earth, it would be moving at its fastest. So it would thus cause a fast-moving tidal event. But the speed would have to just be large enough to overcome friction between this liquid part of the Earth and the outer solid layer. And several tidal events have been observed in Earth's oceans, which have led to ocean currents receding from beaches in several places around the world, such as Brazil, Uruguay, and several other places, including more recently Venice. Since Venice has been through dry spells before, without the water ever receding to the point that the canals are empty, there seems to be another case of ocean recession. If the water is receding in places, it must be piling up in other places. The most likely cause is the gravitational attraction of a massive object moving very fast and coming close to the Earth. The fact that these tidal events are becoming more noticeable seems to imply that this moon may be getting closer to the Earth. If the Earth has gained a new moon, it will most likely also affect the orbit of our original moon, in which case we would most likely see the original moon rise and set at odd times. Also, the increase in tidal events and the continued acceleration in the magnetic North Pole shift suggests that either Earth's original moon or new moon is causing increasingly stronger tidal events and may therefore be spiraling closer to the Earth. Now, an incremental crustal displacement leading to a shift in the magnetic poles positions would also result in a shift in the geographic poles positions. This would then result in the regions known to be close to the original geographic poles no longer being close to the true poles. This would mean that these regions would warm up and that ice sheets in these regions would start melting. Since this is exactly what has been happening in both the Arctic and the Antarctic, it becomes an even greater possibility that the Earth has indeed experienced small crustal displacements in incremental steps. And here we see a map showing deviations from average of temperature for several regions on Earth. And we see that for the world is 0.68, for the tropics 0.52, for the northern hemisphere 0.76, southern hemisphere 0.59. But for the Arctic it's 2.87. For the Antarctic it's 2.54. And this shows that both the Arctic and the Antarctic have heated up much more than any other place on Earth. And this may therefore be what we would expect if we'd had a geographic pole shift due to crustal displacement. and thus the North and the South poles are no longer in the true Arctic and the true Antarctic, and thus they are getting much more sunshine, which is causing the ice in those regions to melt. Now, whether the Earth acquired a new moon or its original moon's orbit was perturbed so that it became highly elliptical, both events are most likely consequences of the fact that the system of old stars, stellar cores, as documented in many articles I've written, have invaded the solar system. These objects would most likely have planets which may end up orbiting the known planets in the solar system. Jupiter, as the most massive of the planets, would be the most likely candidate for gaining a few of these, and indeed it seems that the number of Jupiter's moons has been increasing. Jupiter started out with 16 moons, but the number has gone up to 69. In conclusion, the fact that the Earth's magnetic north pole is shifting in one direction and accelerating suggests that tidal forces are causing small incremental crustal displacements caused by a massive object moving fast past the Earth and doing so repeatedly. This suggests that either Earth's original moon has been affected by a passing massive object so that it moved to a highly elliptical orbit, or the Earth may have acquired a new moon which follows a highly elliptical orbit and which is also moving incrementally closer to the Earth. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.